if the value doesn't equal the sentinel, then sum kind of, adds it into there. But I also need to make this thing stop. And so I'm going to have to rearrange my loop a little bit here, because if you think about what I'm going to try to do, I'm going to prompt and get a value and then either add it in the sum or quit. And then I'm going to prompt and get a value and add it in the sum or either quit. So I have a loop where I need to kind of rearrange my notion a little bit here. And one way I could do this is something like this. I could say this: well, while value does not equal sentinel, then add it into the sum. So I'm going to kind of change my code around. Just sort of watch carefully as I reorganize it. So if the value is not equal the sentinel, then I'm going to add it into the sum, and then I'm going to get the next, and overwrite the previous value. So watch this. Value is this, and I'll go up here and I'll say int value. Okay, so I kind of inverted that loop that was there a little bit. So it says, okay, well, while the value is not the sentinel, add it into the sum, and then get the next value and come back around. The problem with this code as it stands is there's something a little bit wrong about value, right? It's not initialized, right? So I need to initialize it to something. It's like, well, what do I need to initialize it to? Yeah, I need to what the user wants. So in fact, this little piece of code that's down here kind of needs to come up and be repeated up here, right? I need to get a value from them, right? And then go into the, if it wasn't a sentinel, add it and get the next one. This is what's called a classic loop and a half construction, where there's a little bit of things I need to do, and then I need to do some test and then decide whether to go on with that iteration. And as it is, there's kind of a little bit of a half of the loop that kind of starts up. They call that sometimes priming the loop, getting things ready to come into it. And that's a little bit unseemly. There's something about that's a little bothersome, even though it's a very small piece of code. 2 lines of code is not going to rock the world. But I do want to try to get us into the habit of thinking, if we can combine that code and unify it, that's better. It's better than repeating it. Repeating it means that if I ever change something about it, I have to change it in 2 places, that there's an opportunity for error to creep in, that I can avoid if I can get it to where there's really just one and only one version of the truth. So I'm going to change this to, is going to use the break statement, which you may have had a little experience with, which is I'm going to run a while true loop, which looks like it's going to run forever. I'm going to prompt get the value, and if the value equals the sentinel, then I'm going to use break. And break immediately exits the loop here without completing the bottom of this loop iteration, and causes it to move on to the statements after the loop. So by doing it this way, I now have one prompt, right, then a check, and based on that check, I either kind of finish this iteration and keep coming around, or I immediately break out saying that was the clue that we're done with this. You could. I would say that it's a little bit of an advanced question, but it turns out that the do while loop is not really that much cleaner in the end, and because you still have to do the prompt and test and try to decide when to add it in. And do while loops are just so unusual that they cause everybody to slow down a little bit when you read them. So if you can actually kind of write it using a more ordinary loop construct, there is some advantage to that. So I got this guy together here, and then maybe I should actually tell the user, this might be a good thing to say, tell them what the sentinel is. Oops, and I have to type better than I do. If done. Okay. Whoops. And what does like now? Oh yeah, well we better count those number of scores. How about we do that? Num scores equals 0. And then each time we get one, we increment. And so 4, oh that's right, I'm using 4 as my sentinel. Well that's good. 5, 6, and I say 4, then I should average the 5 and the 6. So let's go back. We'll change our call to maybe use a more ordinary value like -1. And then type in 5, 6, 7, 8, 9, and then I can type -1, and the average of those is 7. All right, not bad. All right. So just a little bit, rearranging, getting used to this, kind of seeing this code. Should kind of seem very, very familiar in a lot of ways, but just a little bit of some details, right, that need to be different. I'm going to show you one other little C++ism while I'm here, because it's something that comes up in the standard libraries, and it's worth knowing, is that there's some minor conveniences in the way that C++ provides certain facilities that are not conceptually a big deal, but you do need to know about them because you're going to encounter them in various interfaces. And one is the notion of a default argument. That in the prototype for a function, there at times, and this is no longer num scores, I should really be more clear about this, that's the sentinel now, that there are arguments to a function where it's almost 90 or some very large percentage of the time always going to want to be a certain value, but you still want to leave it open for the user to specify a different value in the cases where they don't want to use that standard value. And so one way of doing that in C++ is to write your function using a default argument where I say int sentinel and I said equals -1. And that is providing for if somebody makes a call to get scores and average passing an argument, it's used instead. If they pass nothing, so they just have open paren, close paren, and they don't give a value for that argument, then the assumption is to use that default. And that means that most people who are making calls to get scores and average, right, can just drop this number and get the behavior of using -1 as the sentinel. But in the case where for one reason or another -1 was one of the valid values that you could potentially enter, you could pick a different one, right, -75 or 0 or whatever it is that you want to use instead by overriding that default argument. We'll see that in the libraries. It's interesting though. The mechanism of it is really quite simple. It's just a convenience, right, for providing for. You can actually have more than one default argument. Subsequent arguments right over there. The idea is that you can only leave off when you're making the call kind of the lastmost argument and then from there other ones because it has to kind of figure out how to match them up. So it matches the arguments left to right, and as soon as it runs out of arguments, it assumes everything from there has to be used its default argument for it to match that call. So it allows for, you could have 3 arguments of which you could specify 2 or 1 or 3 if they all had defaults if you needed that. It's not that common, but it does kind of come up. All right. A little bit of that. Let me go back to my slides a little bit and just tell you about a couple other little mechanisms of, whoops, that's not where I want to be, of some C++ features that are new to us that we want to know a little bit about. There are 2 types of user-defined types that are very simple to get your head around and just want to know what the syntax for them is and what they do. Is the enumerated type or the enumeration, where at the top of your program, so up there where I was defining constants and doing pound includes, this is where we put kind of information for the compiler that is of use across the entire program. This was also where we would put new user-defined types. In this case, I want to define a type direction t, which can take on one of the 4 values, north, south, east, west. And that whole package up there, that enum, direction t, north, south, east, west, is the way of defining the new type. You're saying direction t now comes into the space as a name that can be used for variables, parameters, return types. Any place you could have used int, you can start using direction t. And it has the expectation that variables that are declarative direction t will be holding one of those 4 values. And it's like north, south, east, and west got defined as constants. And they are by default assigned the values actually 0, 1, 2, 3, just in order unless you do anything special. And then you can use them. You can do things on enums that are very integer-like. You can assign them. You can compare them. You can actually use less than and greater than. You can add them. There are things that they are kind of largely implemented underneath the scenes as just numeric types, but they're just a nice convenience for making it clear that this thing isn't just any old ordinary integer. It specifically it should be kept into this constraint range and mean something a little different. So it's just a nicety. Does not have a lot of heavyweight features associated with it, but kind of a nice way of documenting that something is this kind of setup. This one, the record of the struct type, much more broadly useful. Just an aggregate, right, which you can take a set of fields that of same or different type, give them names, and kind of aggregate them together. You can say, here is a student record, and the student has a name and a dorm room and a phone number and a transcript and all these things. Aggregate it together into a new structure type. So in this case, the point T structure type. And so like this is the kind of thing you put up at the top of your code that says, here's what's in a point T, the field names and their types. And a little point of noteworthy error producing is that there really does have to be a semicolon at the end of this. Similarly, there has to be a semicolon at the end of the enum declaration for direction T. If you forget to do that, there's a kind of a cascade of errors out of that are really a little bit mystical the first time you see them. You learn to actually identify this quickly later on, but it ends that declaration and then allows the compiler to move on to the next thing, not kind of assuming you're still doing some more work with this. Once you have this type declared, you can make variables, return types, parameters, all that stuff. And then the access to the members within the fields within a struct looks like access to an object did in Java, where you have the variable name on the left, and then a dot, and then on the right, the name of the field you're accessing, setting, reading. You can do things like P equals Q, which does kind of a full assignment of one struct onto another, so it copies all the fields over from one to the other. So something simple, right, that but does kind of have a lot of usefulness, right? Just it makes a lot of sense when you have a program, right, and you do group things together. Here's all the information about, this part of my data structure, a student, a class, a dorm, all the information being aggregated together into one unit is actually a nice way to keep kind of your data organized. Yeah?
Before I didn't understand exactly how to third line to the end, point t, how much t?
So this is just declaring 2 point t variables, right? One is p, one is in q, right? And then I'm saying, oh, p dot x, so I'm setting the x field of the p variables to be 0. At this point, the p dot y field is nonsense, just garbage. And then I said p equals q, which basically says take the nonsense that's in q and overwrite it onto p and make p be as nonsensical as q is in terms of its contents. Not very useful code. And then the last thing I'm going to show you today is just to talk a little bit about parameter passing. This is going to come up kind of again and again, but this is just kind of a quick first mention of these things. Someone had asked earlier, well, what is the parameter passing mechanism that's in play? The default parameter passing mechanism is what's called pass by value, or it basically to say it copies. That if I have a function here, binky, int x and y, that in the body of it, it tries to do something like double the value of binky and reset y to 0, that when I make a call to binky, and I had a set to 4 and b to 20, that when I made the call to binky, the pass by value really means that the x and y parameters of binky are copies of a and b. They are distinct, right? They are new integer variables, new space, new storage, and they got their initial values by taking the current values of a and b and copying them, but changes to x and y affect binky's context only. And so that 4 that came in here and got doubled to 8, that y that got set to 0, are live here, but when binky exits and we get back to main, a and b still are 4 and 20. So it just did full copies of all and this is true for all types of structs and enums and ints and cars and all that. It's copying the data, operating on a copy. In most situations, that's actually fairly appropriate, right? You tend to be passing information in so it can do some manipulations. In the situation where you really want to be passing in and having changes be permanent to it, change the values, there is an alternate declaration where you add an ampersand to the type. So instead of being an int, it's an int ampersand. And that changes this parameter from being a pass by value to a pass by reference or a reference parameter. In such a case, right, when I make a call to binky, this first argument will not be a copy. The second argument is still a copy because I haven't changed anything about it. But when I say binky of a and b, what the binky function is actually getting in that first argument is not a copy of the value 4. It's getting a reference back to the original a. And then for the y parameter, it's getting a copy of 20. So when it makes this change over here of trying to take x and double its value, it really did reach back out and change a. And so after this, right, a would be 8, b would still be 20. So it allows for you to pass some data in, have it be manipulated and changed, so updated, adjusted, and whatnot, and then come back out and see those changes. That is, for certain situations, very useful. This mechanism doesn't exist in Java, right? There's not a pass by reference mechanism, so this is likely to seem a little bit bizarre at first. We will see this a lot, so this is maybe just our first introduction to this. We're going to come back to this more and more. One thing I will note is that the primary purpose of this is to allow you to kind of change some data, pass it in and have it be changed, but it also gets used in a lot of situations just for efficiency reasons, where if you have a large piece of data you're passing in, a big database, that to copy it could be expensive, and especially for this larger things, right? That copying just so you can hand it off to a function to print it would be unnecessary, and so by using the reference parameter in those situations, you're actually just allowing it to avoid that copy overhead and still get access to the data. So sometimes you'll see it used both for changing as well as efficiency. Okay. I'm not going to show my last slide, but that's what we're going to be talking about on Monday. We'll talk about libraries. So looking at Chapter 3 is the place to go in the reader. I'm going to be walking over to Termin momentarily, and I would love to have somebody come and hang out with me. Otherwise, have a good weekend. You have nothing to do for me. Enjoy it. It's the last weekend in which you will not be my slave.